Hello everyone. Welcome to Agile Rankmate, your partner in education. Today, in this episode of TALLENTEX Overseas 2024, we'll be looking at sample questions on class ninth maths and mental ability. Let's begin. First question on mathematics. If x squared plus y squared plus z squared minus xy minus yz minus xz is equal to 0, then which of the following is true? 1. X is not equal to y is not equal to z. 2. X is equal to y is equal to z. 3. X is not equal to y which is equal to z. And 4. X is equal to y which is not equal to z. So in this, the the first of all, you have to look at the equation and try to find out if there was something similar related to one of the equations that studied that you may have studied, that's such as a plus b the whole squared, a minus b the whole squared, or such sorts. Here you can see that minus xy minus yz and minus xz, so it is a combination of two variables. So it is somehow, it looks like the equation a squared plus b squared minus 2ab. The only difference is there is not the 2 is not being multiplied in each of these cases. However, if we multiply 2 with this, so if we write x squared plus y squared plus z squared minus xy minus yz minus xz is equal to 0. If we multiply 2 to both of the sides, then we get 2x squared plus 2y squared plus 2z squared minus 2xy minus 2yz minus 2xz is equal to 0, because 0 multiplied by 2 is 0. So we have minus 2xy minus 2yz and minus 2xz. So let's from these three we can form three equations. So first of all, minus 2xy, the two variables are x and y, and 2x squared can be written as x squared plus x squared, and if we take 1x squared from that, we get x squared, and we can also take 1y squared from 2y squared. So we get x squared plus y squared minus 2xy as one of the equations. And it is the same form as a squared plus b squared minus 2ab. Now this whole can be added to, now if we take another term with minus 2yz, the two variables are y and z. Now from minus 2 positive 2y squared, one of the terms is already gone, but one of the terms is left, so we can use it over here, y squared. And from z there was 2 left. If we take one of the z squared, there'll be z squared left, and we get y squared plus z squared minus 2yz. And that's the second equation. And the third equation is must end with 2xz, and the remaining variables would be x squared and z squared. So we have x squared plus z squared minus 2xz is equal to 0. Now what is a squared plus b squared minus 2ab? Now this is equal to a minus b the whole squared. So if we use it in all of these, over here we have x and y, so over here we'll get x minus y the whole squared plus over here y and z, so we get y minus z the whole squared, plus in the third equation we have x and z as the two variables, and we have x minus z the whole square is equal to 0. Now over here, one thing you have to notice is that anything squared would be positive. It would that is that if it's a real number, it would be positive, and we are discussing with real numbers right now. So the a squared would always be positive. So, and over here, if any of these terms is uh, anything more than 0, then uh, for example, if x minus y is 1 squared, then any other one of the others must be negative, but it cannot be possible. So the only solution to this equation is x minus y is 0, y minus z is 0, and x minus z is also 0. So from this we can get that x minus y is equal to 0, y minus z is equal to 0, and x minus z is equal to 0. Now if we solve the equation, not solve but equate them, just uh, change the positions. If we take minus y to the other side, we get x is equal to y. Over here we get y is equal to z, and over here we get x is equal to z. Now if we join all of them, so x is equal to y, and we have y is equal to z, so x is equal to y is equal to z. And if we look at the options, we have option 2 as the correct option. X is equal to y is equal to z. Next question. If 2x minus 3 is a factor of this whole p of x, then the value of a is. So over here, we know that if something is a factor of another, then the remainder between them would be 0. For example, if we divide this whole, let's name this as p of x, and this 2x minus 3 as g of x, then p of x divided by g of x would always would be a number, but their remainder would be 0. Now, according to the factor theorem, if uh, if the remainder is 0, then that means that if we take the 0 of g of x, and we take the 0 of g of x, and we replace x in p of x with the 0 we got, then uh, this whole thing would be equal to 0. So for g of x, let's find it out. Let's try it out. 2x minus 3. To find it 0, we have to equate this whole thing is equal to 0. Then we get 2x is equal to 3 and x is equal to 3 by 2. So x is equal to 3 by 2 is the only 0 of g of x. And if we replaced x is equal to 3 by 2 in the whole of p of x, that's basically p of 3 by 2, then we get 2 into 3 by 2 whole raised to 4 minus 3 by 2 whole cube minus 3 by 2 the whole cube, and then minus 3 into 3 by 2 the whole square. Then we're just replacing the x with 3 by 2, and minus 2 into 3 by 2 plus 3 by 2. Sorry, not plus 3 by 2. That's a, not x. So plus a. Now if we simplify it further, 3 raised to 4 is 81, 2 raised to 4 is 16, minus 3 cube is 27 by 8, minus 3 into 9 by 4, minus 2 into 3 by 2. 2 and 2 will cancel each other. 3 plus a. Over here 2 and 16, they can cancel with 2. We'll get 81 divided by 8 minus 27 divided by 8 minus 27 divided by 4 minus 3 plus 9. Now if we find the LCM is equal to plus 9 plus a, yeah, And if we find the LCM, we get it as 8. So 81 divided by 8 minus 27 divided by 8. We convert 27 by 4. We had to multiply both the numerator and denominator by 2. So 27 into 2 is 54 minus 54 divided by 8. And 3 we had to multiply by 8. So we get 24 by 8. And let's remain A as it is. So we get 81 minus 27 minus 54 minus 24, the whole divided by 8 plus A. And if we take all the negative terms, 27, 54, and 24, then if we add them, 4 plus 4, 8, 8 plus 7, 15, 1 plus 2 plus 5 plus 2 is 10, 105. So we have 81 minus 105 divided by 8 plus A is equal to 0. 81 minus 105, we get negative 24 divided by 8 plus A is equal to 0. And negative 25 by 8 is basically negative 3. And if we take negative 3 to the other side, we get A is equal to 3. So that's what we were looking for. The question was asking us what is the value of A, and we found out that A is equal to 3 using the remainder theorem. So option 4, 3 is the right answer for this question. Next question on mental ability. If YAASPYAW stands for accuracy, or ACCURACY, then how will you write this QSAACQQ? Now, if we write it down, if we write the first term down, SPYAW, and according to that, if we write the others below, then we see that there is some relation between the first and the second word, because over here we see that A is being repeated, and also C is also being repeated in the second one. So that means there must be some relation. If we look, Y plus something is A, Y plus 1 is Z, Z plus 1 is A. So we get Y plus 2 is A plus 2 is C, A plus 2 is C. If we look at every one of them, they have 2 additional letters. After it is skipping one letter. So if we add 2 to every one of these alphabets, then you'll get the code. So if we write down Q S A C Q Q, then Q R S, Q plus 2 is S, S T U, S plus 2 is U, A B C, A will be C, C will be E, and Q is S and S. We get success. So option 3 is the right answer. An easier method would have been to so we already observed that there is 2A over here and the others 2C over here. And if we look at the question, we have 2A and 2Q. If we look at the options, in the fourth and the second one, there is no repeating letters. And in the first one, there is only one pair of repeating letters, R and R. However, in the question, we have 2 pairs of repeating letters, which is only seen in option 3, success. So that would have been an easier method of solving this question. Next question, the last question of this episode. When the following figure is folded to form a cube, how many dots would lie opposite to the face bearing 5 dots? 1, 2, 3, 4. So over here, a cube, if this is basically a net of a cube, and you have to find out which are the opposite sides. Now, a trick for this is that every alternate in a straight line is a cube. So, for example, if we take this and this would be opposite sides of a cube. For example, if we imagine 2 as the base and 1 is being folded up, so 2 as the base and this thing is being folded up, and this would also be folding up in the other side. We get that this 1 and 4 would be opposites. So alternate tiles in a straight line are always opposites. And if we take 2 and 6, they would also be opposite. If we take 4 as the center, then we'll get 6 and 2. And the remaining 2 are also opposites, 3 and 5. So what's it asking us? The question is asking us how many dots would lie opposite a face bearing 5 dots. So this is the tile bearing 5 dots. And opposite to that, as we just looked at it, was 3, because 1 and 4 are opposites, 2 and 6 are opposites. The only remaining number is 3. So the tile which is opposite to the face bearing 5 dots would be the face bearing 3 dots, and 3 is the correct answer for this question. That's all, folks. We hope you found it interesting. For more such interesting videos, please subscribe to our channel, Agile Rank Mate. Until the next episode, take care, stay safe, ta-ta for now.